Right, great. Thanks very much for that. Yeah. I have to actually admit that this is the very first time I've done one of these things completely live. I've done these recorded ones quite, but here we go for a live one. So thank you all for coming along to this talk. I'm going to share my screen, which is also a novelty for me. Here we go. And so now hopefully you can see my screen.
Yeah, we can see it.
Jasper, you can give me a thumbs up if you can
see
it. Great. Okay, wonderful. So I'll just go ahead. Okay, so yeah, thank you all for coming along and listening to this talk. So I'm going to be talking today about vegetation dynamics and biome shifts in the Eastern Karoo. And of course, I'd like to acknowledge my my co-author on all of the, sorry, I'm just trying to share my little high laser pointer. There we go. Tim O'Connor, my collaborator on all of the papers and so on that we produced, and the supervisor of my PhD, co-supervisor of my PhD, who was at SAEON until recently. Yeah, so I'm at the Grootfontein Agricultural Development Institute, also known as Grootfontein College, and that's in Middelburg in the Eastern Karoo. And today, what I'd like to chat about a bit is sort of what the Karoo is, with a focus on the Nama-Karoo grassland biome boundary, or the ecotone. That'll be the focus of today's talk. I'll be looking at how vegetation has changed over the years. I'll be looking at the effects of rainfall and the reciprocal of rainfall, drought. We'll look at effects of livestock grazing. We'll look at effects of fire, and then we'll summarize what we've found. So the Nama-Karoo, here's a picture of it. This is from just north of the college, between Middelburg and Colesberg. The Nama-Karoo is a very diverse
Justin,
environment botanically.
Justin, so, oh, there we go. Sorry, the slide transition's a bit slow, maybe.
Okay, so what I'll do is I'll just, okay, I'll pause a little bit before, maybe the picture's a bit big or something. Okay, so the Nama-Karoo is quite a diverse environment with loads of species, of course, but also lots of different growth forms all coexisting together. And the ones that are probably the most well known, and the ones that we'll be focusing on today, are the dwarf shrubs, and they come in two sort of variants: the succulent type and the non-succulent type. And then the grasses, and you get perennial tufted grasses, which are the main focus of today. But you also get perennial creeping grasses, and you get annual grasses, which wax and wane a lot more. And then you get all sorts of other species, which we're not really going to look at today. You get ephemerals, you get geophytes, you get shrubs, you get ferns and mosses and lichens, and all sorts of other things. But today, for today's talk, we're going to be focusing on the dwarf shrubs and the grasses mainly. So, okay, now hopefully it has transitioned to the next slide. Right, so where are we? Here's South Africa, obviously, in the bottom right-hand picture. And that brown area is the Nama-Karoo biome. And if you can see my laser pointer, it's in that red square just towards, or red oval just towards the bottom of it. And that's sort of where we are. So we're right on the eastern side of the Nama-Karoo, kind of where we start almost transitioning into the semi-arid grasslands, which are to the east. And this area it's been realized and pointed out quite early on that there's evidence that this area transitions over time between essentially grassland and Nama-Karoo. And Tidmarsh in 1957 said the way he interpreted it was that the Karoo has grass-felt soils over which at present a Karoo climate prevails. What he meant by Karoo climate, we're not entirely sure, but he certainly recognized that the soils, at least, were of the grassland type. Well, that's what he thought. And then Louis Scott, has done wonderful work and has demonstrated that the Karoo fluctuates between between drier times, sorry, let me rephrase that. It fluctuates between Nama-Karoo and grassland, with Nama-Karoo dominating in the drier times and then grassland in the wetter times. And this can happen over long periods of time. The cycles can be very long, and it's been this way for an awfully long time, at least the last 250,000 years. And now in the 1950s, John Aycock's, the famous botanist who did the Felt Types of Southern Africa book and map, with which we're all familiar, he drew this or a similar map on the top right, showing that he predicted that the deserts were going to be encroaching into the Karoo, and the Karoo was going to be encroaching into the grasslands. And the main reason for this, he surmised, was the effect of livestock, and we'll look at that later. But he certainly felt that this environment was, as he thought, deteriorating, and this biome boundary was punching eastwards and northwards into the grassland areas. So there certainly are forces at work, shall we say. There are things that are driving the vegetation in this environment. Now, on the bottom left picture there, you can see something's definitely at play. On the left-hand side, we have a nice grassy Karoo vegetation. On the right-hand side, essentially, we have stones and nothing growing. And that's the effect of animals, and I'll come back to that a bit later. So that's forces over space, shall we call them, or effects over space. And then on the right-hand side, we have effects over time. There's a picture actually very, very close to where I now live, near Middelburg on the way to Grootfontein. And there's a picture taken by John Aycock in the 1970s, I think 1971. And the photos from the Rephoto, Tim Hoffman's Rephoto setup. Wonderful site to visit if you haven't looked at it yet. So that's a photograph from the 1970s. And then on the right bottom is a photograph I took in 2016, also during a relatively dry period, not a particularly wet period. And you can see very, very clearly that something mega has gone on. The top, not a blade of grass in sight, and at the bottom it's dominated by Hippopogon, Sporobolus. There's some Phemida in there, there's Eragrosty, Digitaria, etc. So those are the types of things that we are interested in and want to explain. So let's first of all take a look at rainfall. What has been the effect of rainfall in this environment? Hopefully showing on your screen is a graph, or it will shortly, and it shows the standardized precipitation index, or SPI, which is currently my favorite way of looking at rainfall. I find it a very informative way. The SPI is quite cool because what it does is it kind of, based on your own data, it categorizes your rainfall over time into periods of relatively normal rainfall, or moderately dry, or severely dry, or extremely dry. And the same for wet, but I haven't actually included that. And this rainfall record that I'm showing here is from about 1888. So it's a lovely long rainfall record that we have monthly data for. And it's obviously very up and down, as is typical of these areas. But we can see a couple of trends. We can certainly see in the early part of the 1900s, it was the area was much more prone to drought, or experienced far more droughts. And in the 1970s, again, there were lots of droughts, and late 1990s as well. And we can also see in more recent years, there's been rather fewer of these droughts. This is at the 1-year scale, so looking essentially at annual rainfall. If we look at instead the SPI on a 4-year basis, we can see more of a trend. And a 4-year scale might be the sort of scale at which vegetation changes occur. They don't usually, vegetation changes don't really occur that rapidly over maybe a period of a year. They normally take several years to manifest. So let's look at it at a 4-year time scale, and the trend becomes very obvious. In the early 1900s, it was a terrible time. There was no rain, and up until the essentially 1940, droughts were very, very common. A lot of the time it was moderately, severely, or even extremely dry. Then in the 1940s and 50s, it hung around normal for a while, and then during the late 50s, 60s, and into the early 70s, rainfall declined over time, and there were very, very severe droughts into the early 1970s. Then in the mid 1970s, there was phenomenal rain. This was across South Africa, not just in the Eastern Karoo, and there was a spike. And since then, actually, the rainfall has been pretty high. So at a 4-year scale, it's only dipped twice into drought, once in the mid 80s, sorry, and then about the 1997 drought. It sort of dipped into a dry period, but nothing very much. And most of the time we've been normal or above normal. And so this, we argue, of course, is a strong driver for the changes that we've seen. Now, I say that composition doesn't necessarily vary very much over short periods, but certainly the relative abundance of the different growth forms can. And so on this next slide, that's entitled Short-Term Responses to Rain, you can see just how responsive the environment can be. It happens in reverse as well. You can go from very dry to very green very quickly. And that is essentially because of drought. On the top right-hand side, we can see what the veld looked like during the early 2010s, which was a wet period, what it looked like in 2016 after a relatively severe, if short-term. And what about the longer-term rainfall? And what about the rainfall seasonality? How is this how has this changed over time? The top left graph there on this next slide shows the distribution of rainfall over the from 1916 to 1989, and then from 1990 to 2008. A little bit out of date, 2008, but actually the differences have persisted, and in fact they almost have strengthened. Now, if we look at that top left graph, we can see a couple of things. See that, first of all, there is more rain, especially during the summer months. So the summer rainfall has been higher for quite some time, certainly since the 1990s and arguably from the 1970s. But we can also see that the seasonality of the rainfall has changed. And that black line peaks in about December, January, whereas in the past it peaked a little bit later, sort of somewhere January, February. And that is of importance to grasses, especially. Grasses want to get an early season start, use the rain during the hot months of the year, and be able to grow and set seed. Whereas if the rain comes much later, then their window of their growth period, the window of opportunity for growing, is much reduced, because we generally get frosts from about even late March. Late March, April, it's starting to cool off, and the grasses just don't grow in the same sort of way. So those earlier rains and the increased rains, we certainly argue, is the main reason for why we've seen this phenomenal increase in grassiness in this part of the world. And the graph on the bottom left, this is rainfall seasonality, also this is from 1880s or something, through to approximately current day. And at the top of the graph, so where it says March on the y-axis, that means that rainfall is peaking and right into the autumn. Whereas if it shows in January, that's when rainfall is falling really during those hot summer months. So we can see also rainfall seasonality might have had a role to play in terms of grassiness. After the 1910s or so, rainfall tended to fall in February or March, February up until the beginning of March. And in more recent years, maybe since the mid-70s or early 80s, it's come forward, and rainfall has been much more concentrated during the warm growing months of January and even late December. If we look in a bit more detail at the actual changes in growth forms that we've seen over this period of time. There's been a decrease in shrubs, so the dwarf shrubs have decreased, and the likely reason for that is through grass competition, especially when the grasses grow really well during the summer. They essentially shade out the shrubs. There's been an increase in grassiness, which I've talked about. And we found that even areas that were severely grazed and historically have become much, much more grassy. So if we look at the graph on the right-hand side, lenient grazing, so that's just under normal grazing conditions, shall we say. The first set of bars shows dwarf shrubs, perennial dwarf shrubs. We can see that their abundance, this is basal cover, by the way, their abundance has more than halved. Then short-lived grasses are the next pair of bars. They've increased probably by about threefold. And then the next two sets of bars are perennial shrubs, perennial grasses. And we can see phenomenal increases there in the abundance of these perennial grasses. That is under normal lenient grazing conditions, but under severe grazing conditions, we find pretty much the same story. Dwarf shrubs have decreased in abundance. Short-lived or annual grasses have increased in abundance, and perennial grasses have massively increased in abundance. So in areas that were heavily grazed by livestock for long periods of time and essentially very bare Nama-Karoo, these improved rain conditions have allowed the whole area to become more grassy. And I'll show this picture again, but when I talk about animals, but I just want to point out that under severe grazing conditions, this, if we look at this, this is an ordination. On the right-hand side shows two sets of trials, the Seligman Old Block trials and the Camp 6 trials, and the species composition in the 1960s. We can see that it was dominated by dwarf shrubs, Pensia and Kana, Chrysocoma ciliata, Eriocephalus ericoides, common Karoo shrubs, certainly not characterized by grasses. And even these severely grazed sites over time have shifted essentially to grassy sites. Not quite grassland, arguably, but nearly grassland. And they are dominated by Fingeruthia, Eniopogon, Erigostis tragus, Digitaria, etc., Aristida diffusa. So even heavy grazing pressure wasn't enough to stop the this transition, essentially this biome transition from Nama-Karoo to grassland. Now the next slide is just something that I find really fascinating. It's such an interesting little snippet, and that is that of Themeda triandra. Now, I presume everyone is familiar with Themeda. It's one of the most dominant and in terms of biodiversity and as a keystone species, and in terms of agriculture is one of the most important grasses in the country. It's very palatable, it grows a lot, etc. It's strongly correlated with ecosystem health and so on. And there on the left-hand picture, we can see a patch of this Themeda triandra that has come in. So this area actually resembles now essentially a semi-arid free state grassland. But the way that the Themeda comes in is quite interesting. It starts off as a single plant, and then it slowly spreads sideways, maybe by seed, maybe by lateral tillering. We're not sure. The seed doesn't travel very fast, but they make these patches, and the patches increase in size. But the interesting thing is that it essentially forms a monoculture. So written at the top there, Themeda triandra invasion, because it's actually acting almost like an invasive species. And there's just a picture on the right-hand side. Inside there, you have these perennial Themeda tufts, and in between it, just bare ground and nothing else growing at all. So although Themeda is a valuable species, where it does come in over here, it certainly is actually associated with a reduction in diversity and a reduction in different growth forms as well. Okay, so that's a few comments on rainfall and general rainfall patterns. Let's look at drought. Now, drought is sort of the opposite of rainfall. And drought plays an interesting role here because we'll look at shrubs and at grasses. We'll start with grasses. Now, the interesting thing about a grass tuft is that it's not a single organism. A grass tuft is made up of a whole lot of different individuals, which we call tillers. So a single grass tuft might comprise, many tens or even hundreds of individual tillers. Now, when a drought hits, that grass tuft starts to die, but they don't all die at the same rate. What you find is that individual tillers die. And you can have maybe 99% of the actual tillers of the tuft dying during a drought, but some might stay alive. So although 99% of individual plants at the tiller scale have died, you might find that a very, very low proportion of those at the tuft scale have died. And what this means is that these perennial grasses just have this uncanny ability to actually survive a drought. They can't completely survive drought, of course. They can die, as we'll look at, but they really do manage to persist longer than one would kind of expect them to, based on the rate of tiller mortality. And here is a graph from an area on one of our research trials. This one's crop. And we look at the grass abundance, the dotted line with black markers at the top. And we had a couple of pretty serious short-term droughts in 2016, 2017, 2018, and 2019. 2016 was the most severe, where only 20 millimeters of rain fell over nearly a 7-month period. And the area really looked very, very dead. But it didn't actually result in a complete mortality of grasses. They went from perhaps an abundance of about 75% down to an abundance of 40-something percent. So yes, the drought affected them, but no, it didn't knock them out completely. Also, we can see that on that same graph, that bare ground, which is the unmarked line, bare ground increased, of course, and we can see that short-lived grasses increase. So the short-lived grasses quite enjoy a drought in a way, because they can just reproduce from seed when when the rains actually come. If we look at, in the next slide, if we look at the effect of drought on shrubs. Now, shrubs are generally very, very drought tolerant. It's amazing how much drought they can survive. I think in part, or maybe in major part, it's because of their root systems. Often they have very large root systems which can store water. Also, their roots go very deep. They can go deep into the underlying rocks. They can explore the cracks between the rocks and really get down deep and find sources of water, and they survive that way. So they're generally pretty drought tolerant, and you can see that in that picture. That's during the 2019 drought. Those shrubs there look as though they should be dead or nearly dead, but we can see on the right-hand side of that repeat photograph that they've come back very, very happily, and all of those shrubs are actually more than alive. I was talking about grass, and in this area there was major grass mortality of perennial grasses, so they didn't quite manage to make it, even through their careful protection of individual tillers. And all of the grass in the right-hand picture are annual grasses, Aristida, diffusa, and other short-lived Aristidas. So these shrubs can generally survive pretty well. They respond to rain. They respond well to positive rainfall. They also respond to drought, but not in quite the way that grasses do. And we don't actually understand quite how these shrubs die. If we look at that graph at the top right there, the gray vertical bar shows the period of quite severe drought. And if we look at the two solid lines, they are the abundance of shrubs at the two different moments. And over that drought, they did decline, but not immediately. And it's not really that strongly related to rainfall. It is correlated to rainfall, but the actual patterns are not very, very clear. So the drought did affect dwarf shrubs, but in ways that we're not very sure about. But they declined, so their relative abundance, if we take 100% at the beginning, it declined to probably on average about 50% of what it was. But we also see the recovery of those dwarf shrubs over time is very, very slow. It took a couple of decades for them to start approaching where they were. So the dwarf shrub component responds much more slowly to good rainfall conditions, and it also seems to respond much more slowly to actual drought conditions. And as I mentioned earlier, it seems as though good grass growth or grasses growing well managed to outcompete the dwarf shrubs. And I think that's why we've seen the decline in dwarf shrub numbers. It's just because the grasses have been big and they've outcompeted them. They've grown over the top of them and taken their sunlight and probably their water away as well. And just an interesting point on this next graph is the patterns of droughts that we've seen over the last century or more. And those red lines are the 10% lowest rainfall years, or in other words, the severe droughts. And the squiggly sine curve is the approximately 20-year drought cycle that we have in this part of the world that we've written about elsewhere. And we can see that the droughts really coincided very well with that 20-year cycle. Early 1900s, the late 20s, the 40s, the 60s, early 70s, the late 90s. And we also see that the latest drought cycle, although there were these droughts, wasn't actually enough to even put it on the map. So again, that trend in rainfall upward seems to be, at the moment at least, a persistent one. Although, as we can see at the top right, the general climate predictions for the area are that it should grow hotter and should grow drier over time, the climate, but we're not really seeing that. In fact, thus far, we've kind of seen the opposite. Let's touch on livestock grazing for a bit. Of course, a very important component in the Karoo. Animals would have been relatively rare or at low abundance historically. Of course, there were huge herds of springbok and so on that came through, but that would have been on a, not all the time, certainly, probably every decade or something like that. But in the mid 1800s or so, livestock, especially sheep farming, increased, and livestock numbers accelerated enormously or increased enormously over time, especially with the advent of the windmill, which allowed water to be provided to these areas that, of course, historically wouldn't have had many sources of open water available to animals. The effect of animals was recognized early on. Shaw in 1873 talked about the persistent and greedy system of overstocking farms has changed the flora, and he presented this back in England after a visit to South Africa. Toit in the final report of the Drought Investigation Committee of 1923 talked about overstocking, the evils of which are cumulative and apparently not generally recognized. And Acox in 1953 felt that the Karoo was formerly a grassland and had shifted to charoid vegetation owing to continuous selective grazing by livestock. And certainly livestock does have an effect. But if you note in all of these, no mention is made of rainfall. So there was a decline in rainfall over that time and an increase in animal numbers. And the changes were generally attributed to the animals and not to the rain. So what are the effects of animals on Karoo vegetation? Well, we have some wonderful data from grazing trials that were run during the 1950s to the 1970s. And during that period of time, rainfall increased a little bit and then generally decreased, as you can see in the graph there. And the treatments that were applied in these grazing treatments were mainly season of grazing. So what they did was establish various trials, some of them seasonal grazing. So for example, grazing only in summer or grazing only in winter or in autumn or in spring, alternatively grazing during the warm season or the cool season, or grazing continuously, or grazing in a rotational fashion, etc. But the interesting treatments are the winter and summer grazing treatments. And some of you might have seen the effects, and we'll look at a picture of that shortly. Here are a few pictures showing, a few ordination diagrams showing the effect of time and rainfall and season of grazing on composition. If we look at the first one up at the top left, those are the Camp 6 treatments, and the red shows the summer graze treatments, and the blue shows the winter graze treatments. And actually, the first axis of the ordination, the x-axis, is actually a rainfall axis, not a season of grazing axis. And so even in the case in those trials where you were applying very severe grazing treatments, it was actually that effect of rain, the effect of rainfall was actually higher than the effect of relatively severe grazing. In the Seligman treatments, it was the opposite. And we see that the red bubbles are far separated from the blue bubbles, and they are on the first axis. And so the overwhelming effect on those treatments, on those trials, sorry, was the summer versus winter grazing treatments. Now, I'll just quickly recap, or not even recap, I should actually quickly explain. Summer grazing is very damaging to grasses and probably other plants as well, because those plants are trying to grow. That's when it rains, they're trying to grow and they're getting eaten off the whole time. So if you graze during summer, you damage the felt. In winter, in contrast, it's freezing cold, everything is generally senescent, it's dormant, and so it doesn't even really know that it's being grazed. So summer grazing is a very extreme treatment and much more damaging than winter grazing. But also you can see that it's only really the summer graze treatments some of the time that come apart from all of the other treatments. So if you apply a very, very severe grazing treatment, and that's that summer grazing, then you shift the species composition and really damage the felt. But apart from that, winter grazing or intermediate types of grazing, they were all kind of similar, you know, there and thereabouts, sort of separated from each other in ordination space to a certain extent. But probably the influence of rainfall in the, shall we say, normally grazed treatments actually overrode the influence of grazing system and so on. And if we look at the types of plants that were dominant in the different treatments, where you had summer grazing, those trials were generally dominated by the shrubs, especially Chrysocoma ciliata, which is very unpalatable. Also Pensia incana, which is quite palatable, but somehow manages to survive. Whereas the winter grazing treatments were dominated by the grasses, especially Eragrostis lemaniana and Aristida diffusa. And interestingly, just a little nugget of information, is tragus. So tragus is a perennial creeping grass. And we found that as rainfall decreased, so the abundance of tragus increased. So it was managing to occupy the space that had been, shall we say, vacated by the other perennial grasses, that especially those that were being eaten out. Now, tragus is very low growing, so it hides away from the animals, so it doesn't get grazed, and it actually responds favorably to drought. And of course, it provides cover and it binds the soil and so on. So it's a natural little drought survivor and soil protector. And I come back to the same picture that I had early on. I've said that, yes, certainly summer grazing is very damaging to the felt, but in terms of species composition in the face of major increases in rainfall, the effect of summer grazing or of any grazing was largely negligible. This ordination again shows the transition, even under severe grazing, over time with increased rainfall from a unpalatable shrub-dominated Karoo type to a grass-dominated one. Essentially a shift in some cases to grassland. I just want to point out as a bit of a caveat here that I'm not saying that animals don't have an effect. I'm saying that rainfall has a bigger effect, but certainly you can get overgrazing in the Karoo, and there's a picture of it to show it. Slightly different vegetation type, but this picture was taken recently, and despite years of relatively high rainfall in that particular environment, heavy summer grazing by sheep on the right-hand side certainly did knock and retain in a degraded state that vegetation type. So certainly animals do have an effect and can have an effect, but what I'm saying is that in general, the effect of rainfall is a greater one. The last major driver that I'd like to look at is that of fire. Now, I was told I had 40 minutes and I'm on 33, so that should allow us just about the right amount of time. So in the Karoo, fire is relatively uncommon, actually very uncommon. And the reason it's uncommon is because there's not normally enough grass to support a fire. But with the advent of grasses, especially in the eastern Karoo, so there has been an increase in the amount of fire, and in high rainfall years or after high rainfall years, the number of fires radically increases because now there's grass to support a burn. However, even during these years, it should be noted that the overall extent or proportion of the Karoo that's burnt is actually very low, not more, probably 1%, 1%, or even less than that, probably even less than that most of the time. In contrast, the Karoo Mountains, like the one you can see of that image that was taken by a drone, the Karoo Mountains burn much more commonly, and they normally lit by lightning, and then it carries it. But remember also, Karoo Mountains, certainly in the eastern half of the Karoo, are actually grassland biomes. So they, as are most grasslands, are adapted to fire. Nama-Karoo biome. Now, the effects of fire, of course, can be catastrophic cases, and here we have a picture of a piece of veld near Prieska, just to the west of Prieska, which is further west and further north of us, on the Orange River. And a fire burned through this veld a few years, 2017, I think it was, and the effects on it were absolutely catastrophic, including to these cuckoo trees. And but although interestingly, this wasn't actually a fire because of an increase in grass. This was a fire because of drought conditions. And what actually happened here was that the euphorbia and other succulent plants, like the ones you can see growing at the bottom of that aloe on the left-hand side, they died. These were top killed by drought. They senesced, and they actually became flammable. So they're normally not flammable, but they became flammable. And then with human activity in the area was lit, and these senesced succulents actually burnt and carried the fire through this vegetation type, which is obviously, one could term fire naive. It doesn't know what to do with fire, and it killed almost all of the species there. But anyway, what is the effect of fire in the Nama-Karoo in general, and certainly the eastern Karoo? Well, we've done some work on this, and this appears to be a response that is general over the whole of the eastern Karoo. Wherever you go, that you get this type of response. And that is, if a fire burns through, firstly, the grasses survive. So the grasses don't mind fire, they survive. They are knocked back, they're smaller and so on, and the biomass is lower. But in general, it seems as though all, or nearly all, individual grass tufts actually survive. Then dwarf shrubs may or may not be killed by fire, and that's a function of their species. And about 80% of dwarf shrub species actually survive the fire and resprout after the fire. However, some dwarf shrub species are killed, and it's often the ones that are dominant. And in particular, the species that are killed and are often dominant are Eriocephalus ericoides. You can see there in the bottom left-hand picture, with the white flowers, and also Ruchia intricata or other Ruchia species. And they are killed by fire, and they are often dominant in areas. So although most of the species of shrubs survive fires, a fire might kill most of the actual plants. And that's why you get that effect that is shown in that top left photograph. On the left-hand side is an unburnt area, and that is dominated by Ruchias and Eriocephalus plants. And you can see that as classic Karoo shrubland. On the right-hand side, those dwarf shrub species have been killed, and that Karoo felt is now not a dwarf shrubland anymore. It is essentially a, shall we call it, an arid grassland. There are some shrubs in there, but it's mainly bare ground and grasses, and has essentially, in a way, shifted from Nama-Karoo to grassland. Whether this persists over time remains to be seen. It probably doesn't, but one can certainly imagine that with an increase in fire occurrence, one would expect a decrease in shrubs. And so with the increase in grassiness, you'd also, in the ecotone, you'd also expect an increase in fire, and that might also have an influence in how far that biome boundary actually pushes into the Nama-Karoo. Right, so those are some of the main drivers that we've looked at in this part of the world. And so, what's a summary of our findings? I think our overall main finding is that rainfall is really a very, very potent driver of composition in this part of the world. And probably historically, it was underestimated how important a driver it actually was. And this increase in rainfall, when you have periods of high or times of high rainfall, that pushes the biome boundary, the grassland boundary, further west into the Nama-Karoo. And then during dry periods, we presume that the Nama-Karoo would punch further east into the grasslands. Animals certainly do have an effect on grazing, on composition, but there are a couple of important things. Firstly, the effect of grazing is generally secondary to the effect of rainfall. Not always, and there are cases where grazing can have very pronounced effects and persistent effects. But in general, rainfall appears to override the effect of grazing, especially in, shall we say, normal or leniently grazed systems. So, for example, most of the farms and so on in this part of the world. And then in terms of fire, increases in rainfall, of course, results in an increase in grassiness. Increase in grassiness leads to an increase in fire, and an increase in fire may lead to a shift in that grassland biome boundary, where the grassland biome presumably would shift further into the Nama-Karoo biome. So that is my blurb, and all that I need to do is say thank you all for your attention. So back to our host.
Thanks so much, Justin. That's yeah, really cool. Thank you so much for sharing your intimate knowledge of the system with us. It's you know, I think many of us have passed through and maybe spent brief periods of time thinking about Karoo ecology, but to be immersed in it, even if it is only for 40 minutes, is really cool. And it's got me thinking lots of things again. So very, very nice. We have a few questions that have come up in the chat. Some of them are related, so I'm going to try and summarize them into a few questions. The one was kind of around the rainfall trends you were showing and drought, asking kind of what has happened in the last few years with the big droughts that have been happening in both the west and the east of the country and slightly oscillating. What's happened to you in the middle? Have you been heavily hit by drought, or has it been somewhere vaguely normal, or just like shifts in rainfall seasonality because you're either getting your rain from the west or from the east, depending on who's getting rainfall? That kind of thing. I don't know how badly have you been hit by the drought, I suppose.
Okay.
Yeah.
Okay, so we've had since 2016. So 2016, we had quite a severe drought, a seasonal drought, shall we call it. So it was for about 6 months, and that's kind of repeated itself over the years. But we have had some decent winter rainfall. And that's, I think, been the general trend in the eastern half of certainly eastern third, maybe eastern half of the Karoo. Although the summers have been very, very dry, there has been winter rain and people have pulled through to a certain extent. In terms of agriculture, people certainly felt it because there was almost no growth. There's no productivity. So in terms of livestock agriculture, people were hard hit by the drought. Compositionally, however, I don't think that there's been much change. Certainly there has been a die out of perennial grasses, but I think that they in general are coming back. So I haven't seen sort of biome shifts. I haven't seen, a collapse of, the perennial components of grasses. Not completely. In some areas, I'd say that the perennial grasses have died out maybe 80 or 90%, but with the rains, it seems to be bouncing back. Yeah. The shrubs don't appear to have been affected in this part of the world. However, if you look at the western half of the Karoo, I think it's a very different scenario. So once you get out to, sort of Calvinia, Williston area, I think it's a very different scenario. Yeah. There, it appears as though there's been major mortality of grasses, and I think often they've been largely wiped out, sometimes coming back in some areas. And I've also heard reports that actually in some areas the shrubs have died. So I think the drought in the western Karoo can be considered to be a catastrophic or near catastrophic drought, whereas the one in the eastern Karoo probably less so.
Yeah, I know reports from Helga and others in SAEON have been that the western side has had very severe drought. Yeah, it's kind of interesting because you think, many of the shrubs that you mentioned are species that extend, very far west into the kind of more winter rainfall, true winter rainfall areas. So you'd imagine that they're quite happy with winter rainfall, but that lack of productivity in the summer is probably a great benefit to them if they're getting enough water to make it through. To knock out the grasses and let the shrubs take over again. Very cool. So look at a couple of the other questions. Yeah. Sue, I know Gina has a hand up. Gina, do you want to go now? Because I think you wanted to talk about rainfall, perhaps, based on your comment.
Thanks so much, Jasper. Hi, Justin. It's always so great to listen to your talks. I've been wrapping up my thesis, and I've been thinking a little bit more about resource use and grass shrub competition in the biome transition, and specifically of soil, carbon, and water in the summertime. Your data shows quite nicely the competitive effect of grasses on shrubs, but I was wondering if at any of your sites, if you've seen an increase in vegetation cover, almost like a greening, or is this maybe confounded by the grazing effect? Because, the findings from my research show quite an impressive increase in vegetation cover across the rainfall gradient of the eastern Karoo. And so I was wondering, is there a combined influence on rainfall and temperature, on how shrubs and grasses are using certain resources at certain times of the year, maybe? I don't know if you're doing any experiments on this, but yeah, I thought maybe you could comment on this if you wouldn't mind. Thanks.
Yeah, sure. Thanks, Gina. So has there been a sort of a general greening? I mean, there has just been a increase in overall cover in this area. I don't know how that extends, but I think it's not just where we are. It definitely does go further west. You're seeing a whole lot of perennial grasses that in the past you didn't. How they interacting with each other and so on, we're not I haven't got any experiments and so on in that regard. And you mentioned soil carbon. Also, we're not measuring soil carbon, but I'd be surprised if there has actually been an increase in soil carbon, because when these droughts, these seasonal droughts do hit, I mean, or above ground growth stops and almost everything is gone. The shrubs are reduced to little sticks, and the grass leaves are totally gone. In fact, it's absolutely amazing that anything emerges after that, because it's just bare red soil. And I would say that any carbon that was sequestered, microbially or whatever, would just be lost in those incredibly dry, incredibly hot conditions. Temperature-wise, I mean, the variation is so high. I don't know if we see a temperature effect. I personally doubt it. It's too small compared with the variation that you get, and compared with the overwhelming effect that rainfall has on the actual system. So I don't see any real temperature effects. And carbon, I'm not sure about, but overall cover, it's certainly in the survival of individual plants and especially perennial grasses, yes, it has increased.
Thanks, Justin.
Yeah, I had the thought when you showed the standardized precipitation index figure, and you probably don't have the temperature data, but it'd be interesting to look at the standardized precipitation and evapotranspiration index for the whatever period you have temperature data, because that, in lots of areas, SPI looks normal, but if you look at SPE with the temperature, it's a much drier climate. Obviously, it's a proxy for evapotranspiration, so it's not ideal, but it's better than none. Yeah. Yeah.
Maybe I can just add one more thing there, and that is one thing that I think is very, very under-researched. I certainly haven't looked at it, and I really would like to one day. And that is the effect, not just of rainfall, but of humidity. If you have humid weather, or weather that's, above 30, 40% or something humidity, which is relatively dry, but I mean, things grow fine. But when you get really dry conditions, you can have winds blowing for days on end. The temperature can be up in the upper 30s, 40s. And your relative humidity, we've measured at the flux towers in collaboration with EMS Africa. The humidity we measured one afternoon at 1.8%. So, I mean, that is phenomenally dry. Now, any plant would suffer during that. And you can imagine months of that, like we had in 2016, would have I'd imagine would have a huge effect on the survival of plants. So we look at rainfall, but I think, yeah, we definitely have to look at actual, the evaporation and evapotranspiration and so on as well to get a better picture.
Yeah. Yeah, I think linked to that, Johan was asking about whether there was data on soil moisture as a driver of the system. So like, the persistence in soil moisture, I suppose, after rainfall events and that kind of thing. He was also thanking you because it's a great long-term ecological research talk. But I don't know, I don't know if you have any soil moisture data or if that's a recent thing with the flux towers.
So soil moisture data, we do have some, but only since the flux towers started. Lisa Hebelman is writing up, is looking at soil moisture a bit in her thesis at the moment, but we haven't looked at it in detail. But Guy Midgley is doing some work, and he's certainly looking at soil moisture. So it's something that we are starting to, or others, not really me, others are starting to actually look at, and I think it's just so important. And it does, the one thing, however, it is tricky to look at soil moisture, especially with shrubs, because what you have in many of these areas is you get down 30 centimeters or 50 centimeters, and then you hit a layer of sandstone. And you think, oh, well, that's that. But that's not that, because it's cracked sandstone and it's all fitted together like a nice puzzle. And so it's got these little cracks in between. And when you pull those out, it's because we had to dig some holes at one stage, you find that these shrubs actually, the roots come down through that crack and then move along sideways for a little bit, and then down the next crack and sideways, and they really explore deep soil moisture things. So we'd have to look at that in some way. How you go about that, I'm not really too sure.
I think that'll be a challenge. I think Sue and I touched on the same thing with your comment about Thermida. Sue's comment was that in growth trials that were done, they'd found that the Free State form of Thermida was very responsive to increases in temperature and less frost, whereas the grassland one was much less responsive. And my question was, yeah, just whether or not you were able to, well, whether or not you would be able to check whether it was the local form you have or an alien form. I recently found Thermida in the Cedarburg, which was over 2 meters tall, and it's definitely not the fynbos form, because there's no record of a fynbos form taller than 70 centimeters. And when I chatted to the farmer, he actually said, yeah, that it appeared when they'd got like a load of hay or something like that. And fortunately, he was very responsive and actually pulled it all out and has done follow-ups. But I'd be interested to, you know, whether that's a possibility in your case.
Okay, that's very interesting. So I haven't checked that out, and it would be a useful thing to check out. Based on its growth form, I would think that it's the same form that we get a bit further to the east as the rainfall increases, and it looks it looks the same as the type that you get in what they call the Caroid felt, or whatever it's called, and then also, you know, the typical Grootfontein sort of, you know, Western Free State type forms. It does look like those. It doesn't look like a Natal form or KZN form, Drakensberg form. It has that typical sort of growth form, but we must really do that. We must get some DNA and send it off and find out what it is.
Yeah. Cool, thank you very much. There are more questions, but we've hit our hour, so I think I should probably leave it there. If people have more questions for Justin, his email address was in the calendar invite that I sent with the seminar, and I apologize if I didn't ask your question. But yeah, lastly, just thank you so much, Justin. That was really, really cool, really interesting, and yeah, fun. And I'll post the video and the link in the next couple of hours, depending on my internet speed. And lastly, just to advertise, next month's talk is going to be Zach from the Ulwazi node. He's going to be talking about the SAEON's data portal and the development of the portal, and how you can now start to play with it. Cool. Thank you, everyone, and thanks, Justin.
Right.
Cheers. Thanks.
Thank you. Thanks very much.